Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced Stream Junior. I'm Richard. I'm Richard on the MakeCode forum.
I'm Joe at J1Drill on the MakeCode forum.
And is kind of tradition with our junior streams, we're going to be doing a really advanced thing today, probably. Which is, yeah, it's just junior because Joey is J and I'm R, so you know it works. But yeah. We're back to working on our Antron game. Joey, what's Tron?
Tron is a game where you play with motorbikes and then draw lines, and you want to get other people to crash into your lines.
Exactly. So we've got we made this a week ago on Friday, I think, and the idea was you just keep going until you can't go any further, and whoever has the longest path wins. So I just won that round. Take that, AI. And we also made a little AI to play against you, which isn't super good right now, but we wanted to make an AI that was impossible to beat, basically. And so we had an idea of how to do it. We mentioned it at the end of last stream. But the idea is we're going to do something called breadth first search. And the idea behind breadth first search is this is something you use a lot when you're working on like a big area or something. You need to go out and you're looking for something. And in this case, what we're trying to do is at any point while we have this AI running, we can do one of two things. Well, I guess we can do one of three things. We can keep going forward, we can turn left, or we can turn right. So the idea is we want to make it so that when we turn left or turn right, we're making the best decision at that point. And the best decision is whatever puts us in a better space. So like a space with more open area. And so the idea we had was whenever we have to make a turn, so whenever we're about to hit a wall, what we do is we do breadth first search. If we go left, we do breadth search first. If we go right, whichever one has more area, that's the direction we will choose because it's probably the best one for us to do. Yeah, so that's the basic idea. We'll get more into the specifics of how breadth first search works in a bit. I mean, maybe we'll try to do some fun visualization stuff so you can see it happening. But yeah, let's get started.
Yeah. Do we only have to do it when we hit something?
I think so.
I guess to start with, for sure. It might.
The only time we're making a decision, like we're actually cutting something off, is when we're at a turn, right?
That's true in a simple case, at least, right? Like you can be aggressive. Like if you're not going to antagonistic, that is true. If you wanted to be antagonistic and try and cut off the player, but that's a lot more.
Yeah, I don't know if we have a plan to do that right now. We're just going to make one that's like survive as long as possible. Is the basic thing I think we're going for.
Like try and beat other AI.
Yeah. And this still won't be perfect, I'm sure there's a much better AI out there for Tron, but we have to do it in blocks, so we'll do our best. Okay. So let's go ahead. Let's just do a brief reminder on our code. So we have a lot of stuff up here, all of these button handlers and things. These are just the basic Tron game. So this is all of our controls. We have our player 2 controls also. And then these two are our win and lose. So if you overlap with one, with the background, then player 2 wins, and we have another one for when player 2 overlaps with it. The rest of this is we have a little on-game update right here, which is calling a move function that moves our players and calls our AI function for our player 2. And we made a few player 2 AIs. Let's see. So we made this one, which was perfect right turns. It would always turn right if that was like as soon as it was about to hit things, and that's basically all it did. I don't know what's different about this one. That might just be a copy that we never got rid of. And then we had Joey's idea, and Joey's idea was we always go we make perfect turns like we were before. And then there's like a 2% chance that we just randomly turn sometimes. Because when you always make turns like in a normal way, you end up just kind of looping around on yourself. and you end up cutting yourself off. And so it's actually not that good a strategy. So having random turns just made it so that you would, break that up, which worked pretty well. That's the AI we have running right now. So we're going to make another one, which is going to be our BFS one. BFS is breadth first search. You'll probably hear me say BFS a lot. And so let's go ahead and make a function, which is going to be our BFS. We're going to go ahead, put this in here. We'll call it breadth first search. And the idea with this is we are going to return a number from this, and that number is how far you can go, or how many layers deep we got while we were doing a BFS. And we will probably put in a limit on this, because otherwise it's going to be really, really slow. All right, so to begin with, we're going to pass in two numbers. One is going to be our start X. One is going to be our start Y. And then let's see, do we need to pass in like a direction, like go left or go right, or?
Start X, start Y. I mean, it's just gonna be a fill, right?
Yeah. We don't really need to. Yeah,
I mean,
we're good.
Yeah, we might need to do it in a if we recurse or something, but not.
Yeah. I don't think we're gonna recurse though.
Yeah.
Usually do BFS iteratively.
Yeah. Well, I'm thinking. Wait.
No, I guess you do.
I mean, yeah.
Well, we're gonna do it iteratively in any case.
Yeah.
I think it's gonna be.
I mean, either way, it could be done either way. They're equivalent. What was I? I was thinking something. Oh, is this right now probably going to end up, if we don't have any randomness involved, it's probably going to end up as the same as a right turns only at the start, at least for a little bit.
For a little bit until it starts getting boxed in. Yeah.
Okay, we can see when it comes to that.
Yeah, because if we put in a depth, there's so much open space here, it's just always going to hit the depth.
Yeah.
Right. So we wanna just make it so that we can do our best to once we start getting boxed in, we can try to play around with the depth and see how much we can do without running out of CPU time. Yeah. And then and then go from there, because we could just run a perfect BFS of the entire map every single frame, but it's gonna make our game super slow. So,
yeah.
Okay, so basic BFS. What you want to do is we're going to be storing locations. So a location is an X and a Y. And we're basically going to have a queue of these locations that we're going to check. So for each of our locations, we're going to put it into the queue. Then each iteration, what we're going to do is we're going to take it out of the queue. We're going to say like, oh, here's an X and Y. Let me check. Is this one filled in? If it's not, then that's great. What I'll do is I will say, keep doing this BFS in each of the 4 directions, and I will add all of those to our queue. So I'll say like, okay, the pixel ahead of me, that's going to go in our queue. The pixel to the left, the pixel to the right, the pixel behind, all of those are going to go into the queue. I'm also going to mark off this one as visited so that I don't go to it more than one time. The idea is that as I progressively visit all of these things, they're not going to be going into the queue if I visited them already. And so we're eventually just going to match all of the nodes. And what we're going to return is the farthest path that we made, the farthest depth that we did. So for each of these ones, we want to keep track of what our farthest depth is. So with each node, we're going to be storing 3 things: the X, the Y, and the depth, right?
Mm-hmm.
Yeah.
Do we need block object, or are we just going to do parallel arrays?
Yeah, I'm just going to do one array.
Okay. Yeah.
Just going to make a function that is going to take in 3 numbers. Make, usually you call these nodes, so I'm just going to use the word node. Make node, and it's going to take in a X, a Y, and a depth. And then all this is going to do is we're going to go into here. We're going to make a list. Well, actually, we don't even need to make a list. We can just straight do a return. Maybe we don't even need this function. Yeah, whatever. we're just going to return x, y, and depth. Like that. And that'll be our node. Okay. Now we're going to make a variable called q. Always a fun word to spell.
Okay.
Q. Q. It seems like it should be QU, you know?
Yeah.
Okay. And what we're going to do to start is we're going to call our MakeNode function. So actually, can I right click on this and get a, yeah, nice. No, I wanted the other kind. There you go. And for this one, we're going to call our start x, start y, and the depth is 0. And now what we're going to do is we're going to do a while loop. And inside this while loop, we're going to make it so that we check the length of the queue. And if the length of the queue is greater than 0, that means that we still have things to look at. So when it gets to 0, that means we are done. All right. So now what we're going to do is we're going to say current node. We're going to set our current node to be whatever is at the front of the queue. And you don't technically need to take from the front of the queue, but we're doing breadth first search, and you want to take from the, wait. Yes. Yeah, you want to take from the front of the queue when you're doing breadth first search.
Yeah, I mean, here's a secret for all of the people who are doing like data structures and algorithms course. Depth first search, breadth first search, Dijkstra's, A-star, they're all the same thing. There's just like two differences between them. There's the data structure used. So it's Q for breadth first search like we're doing because you want to take out the first thing that was put in. Stack for depth first search because you want to take out the latest thing so you can go deep in first. It's a priority queue, or there's a heap for Dijkstra's and A-star because it does its own thing. It gets a priority based off how cool it is. But they're all the same thing. You just swap it out.
That's correct. All right. So what we're going to do here is one other thing we have to do when we're doing this breadth first search is we need to be able to mark which nodes we've visited. And so I think the easiest way to do that is we're just going to make another background image. This game is definitely not going to run on hardware. So we're going to do this. We're going to say this is going to be a new variable, which is going to be our breadth first search visited, vivid.
Yeah.
And it's just going to be one that's the entire screen. Okay. What's up?
I'll try to think if we could make it run on hardware. I think it'll still, like memory-wise, still work right now. Just barely.
We have 2 background images.
Yeah, that's 20 kilobytes. We have like 40 kilobytes of flex space, and we don't have anything else going on.
Really? I didn't know that.
I think so.
Maybe it will. Okay. So while we're doing this, we're going to now go ahead and mark this off. So we're always going to get the value at 0. We're going to go into our visited. So let's go ahead and go into here. We're going to do the set color at. And we just need to set it to something to not be transparent. So we're using this to store information. Really, we could just use 2 arrays of Booleans. But images are really handy for this just because they already have an X and Y, and we can just map it directly. So, we're just going to do that. It's way easier. So let's go ahead. We're going to do our breadth first search visited. We're going to set the color at the current X and current Y. So that is the 0 and 1 from our node. And we will set it to be pink. And I think, wait, why are you mad at me? Oh, it's, I should probably be doing this on beta, huh? Oh no, I did this wrong. There we go.
Yes. Okay.
Got it. Yeah. Okay. That was my bad. So we want this to be an array of nodes. We don't want it to just be a node. All right. So we're going to go ahead and set our color to be here. And for fun, we want to see this code executing. So we're going to go ahead and we're going to make a sprite for this. And this will make it so that once we start running this code, we can see this getting filled in while we're doing a breadth first search. We'll have to pause while we're doing it, so it'll make it a little bit slower, but it'll be good to kind of visualize what's going on. So let's go ahead. We're just going to duplicate this. We're going to change this to be our breadth first search visited. We're going to set the kind to be food, our general not doing anything. And we'll make this a new variable, which is going to be visited sprite. Okay. And one other thing I forgot to do, we want to make sure that whenever we're doing this, we clear it. So let's go ahead and go into here. We're going to do a fill of our breadth first search visited with transparency so that everything is marked as not visited. All right, so we've marked our thing as visited. So what we're going to do now is we are going to, for each of our surrounding ones, we're going to check to see if they've already been visited. And we're going to check to see if they are, well, I guess we can just check to see if the current one is painted in. And then for all the other ones, we just check to see if they're visited, right?
Current one is painted in. And yes, that sounds right.
Yeah, that might technically return one higher than we want, but whatever. Let's subtract one.
Yeah.
All
okay. Arbitrary anyway.
Yeah, it's all arbitrary. All right, so we're going to go into here. We're going to go to images. We're going to do a get value at. So let's go ahead and do that. Get the color at right here. We're going to get the color at our current X and current Y. So that's just our current node get value at 0 and our current node get value at 1. We want to turn this to our breadth first search visited. And if it equals 0, which means it's transparent, sorry, we don't want to do that in breadth first search visited. We want to do that in the background, the game field image. Okay, so if this is transparent, that means we should keep going. So that means we're going to now look at all of our ones beside us, see if they've been visited or not. And if they haven't, we're going to add them to our queue. So let me go ahead and duplicate this. We're going to change this to be our breadth first search visited. And now for this color at, we want to check it in all 4 directions. So we're going to do X plus 1, Y plus 1, X plus 1, Y plus 1. You know, we're going to do all the combinations. Sorry, X plus 1, Y minus 1, Y plus 1, X minus 1, whatever. So let's go into math. We're just going to make this easier for us to copy paste. We're going to go ahead and put in this minus for both of them. And then we're just going to change the values. So let's go ahead and do that. Duplicate, duplicate, duplicate. All right. So we're going to go into here. We will do an if. We're going to put this right here. We don't need to do an else if for this. We actually explicitly don't want to do an else if for this. And inside of here, I shouldn't have copied and pasted this. I always copy and paste too early, you know? Like finish writing the thing so that you can copy and paste the entire thing, Richard. All right, so we're going to go into arrays. We're going to have an add value to end, and we want to add this make node again. But this time we're going to call it with this same thing that we're doing. So go ahead and get this and this. And for the depth, we actually just want to do the current node get value at 2, which is the last thing, and we want to add 1 to it. So that it's always going up. Yay. So we got that going. Now let's copy and paste this 4 times. 3 times. So we have 4. Oh, wait. We got to check the bounds. No, we don't. No, we don't.
Because it'll return 0 outside the bounds, yeah?
Yeah, it'll return 0 outside the bounds, which is bad. That would mean we would go on infinitely. But if you remember, we did a fun little hack in our game where we put a border around the background image.
Oh yeah, okay. We just need to do that again for this.
So it works perfectly. That'll always show up as something that is in the background image, so it's going to stop there. We don't need to do that usually. That's good because that would have made our blocks way longer. Okay, so we're going to do our x minus 1 for this one. We're going to do our x plus 1 for this one. We'll do our y minus 1 for this one. And we'll do our y plus 1 for this one. Okay, and now what we're going to do is we are going to put in a pause. This pause is just so that we can see this happen. So we're going to be calling this inside of on-game update. And if we didn't pause, the screen will not update until on-game update is finished. So because we haven't finished on-game update until this entire thing has finished, we'll only see it for like 1 frame while it's doing its BFS. But we want to see it. We want to see it like going out. And so to do that, we need to do a pause. And also to do that, we need to make sure that we're doing this not inside of on-game update, because if we do it inside of on-game update, then we get into an issue where, let's see, can we do this?
If you go to JavaScript, we can call the force refresh, but I don't think that there's a easy way to do this unless we, we can put a lock. We can put a pause and make it so in on-game update we just ignore. Yeah,
that's not a bad idea.
Just a global Boolean.
All right, we'll do that. So we're gonna make a variable which is gonna be called move lock. We're gonna set this to be true inside this function. We're going to set it to be false. Whoops. The end of this function, I never would have thought of this. Thank you, Joey. And now what we're going to do is inside of our on-game update function, we're going to take this, move it out of the way. We're going to go into here. And basically, we're going to say we only want our game to go forward if our move lock is not happening. And so now what we can do is when we want to run our AI, we'll just start this function. Move lock will become true. And when it finishes, move lock will become false. It'll go again and trigger the breadth first search again. So.
And we will need to pull in time. Run in parallel.
Yeah, we're gonna have to pull in timers. Yep. So let's do that right now. Timers. This is going well. We're gonna have BFS done so fast. Okay. So what we want to do is we are just going to go into here. And we're going to call BFS in both of our locations. Well, I guess maybe let's just do another function right now. We're going to do a player to AI BFS. So what we want to do in this case is whenever we run into a wall, we're going to make a decision, right? So we need to either go left or we need to go right. So we're going to mark the pixel that we're currently at so that that's marked. Then we're going to run BFS in the pixel to the left, in the pixel to the right, and we're going to see what it returns. We're not returning anything right now, but we'll be able to see the BFS going at least. So let's go ahead. We're going to go into one of our other AIs and just copy and paste some code because it had the check we wanted to do. Let's see, we want Joey's idea, and we want this one. So if we have this check-in direction function, which says if we keep moving in this direction, will we hit a wall? Then what we do is we say, okay, do we want to turn left or do we want to turn right? But we're going to take this out for now. Actually, we'll leave this in because we're not actually going to do turning with this BFS. I just want to show the BFS running. So what we're going to do here is we're going to go into our BFS. We're going to call our BFS function. So let's go ahead and put this right here. We're going to call it with the like left and right, depending on our direction. And let's see, I don't have an easy way to get that. I'm just going to have to write a big if statement. Where's my check-in direction function? Okay. So what we need to do is we want to stop that. Okay, so we don't want to do a return here, but what we want to do is this has the different cases that we want. So we want to do if the direction equals 0, then we want to do the top -1. Oh, I just did my normal thing. That makes sense. So we actually want to do the opposite though. So if direction equals 0, then we want to do the left and right. And so that will be the 1 and 3. So we're going to call it with this. And we're going to call it with this. All right, now we'll just get rid of the rest of this. And we'll make it stop being angry at me by changing this to be player 2 facing. And changing this to be player 2. Beautiful. And now we're going to go ahead. Why do I have 2 pluses in this? Get out of here. Now we're going to go ahead and do it for our other directions. So this is up. This one's right. So for right, we want to do the up direction. So that'll be the y -1. Wait a second. Wait a second. This should be left +1 and left -1. I did that wrong.
The 0 is.
Yep. It's always just going to be the left and right are going to be the same, and up and down are going to be the same.
Yeah.
There you go. Just like that. All right. And the other thing we want to do is, so right now, this is going to run into the issue where we're going to be doing our BFS right, but we're actually, this is going to be a little tough because what I'm realizing now is that we need to do that run in background thing we were doing.
Mm-hmm.
Let's see, breadth first search, get over here. Move lock, come out.
Wait, do we not just put that yeah, around the whole thing?
Yeah, so we're going to move this out here. We're also going to take out this fill. I'll show why in just a second. Okay, so now out here, we're going to do our separately do. But before that, we're going to do our set move lock to true. Now we're going to do this. At the top of this, we're going to do our fill with transparency. And at the bottom of this, we're going to set our move lock to be false. And the last thing we need to do is so we need to set our BFS visited to be true for the pixel that we're currently on, or else we're going to run into the issue where it's going to just go left and right. We don't want it to.
Yeah.
Yeah. So let's go. Where did I put our BFS guy? Right here? No.
Yeah. 1 second.
Oh, BFS.
Just in case. I don't think. Does it matter if we don't reset it between the left and right choices? So if we don't reset it between the left and right, then it could turn left when right had a path back, but I guess then it would also transitively have a path the other direction. So it would arbitrary choice there is fine.
Yeah, it would basically just be the same thing, but let's do it to be safe. So there's a chance that what Joey's saying is right. So we're going to take this fill, we're going to put it up here. We're going to also do this, that, and we'll just always do it here with player 2x and player 2y. So that'll make it so it runs fine. All right, I hope you're excited because we're finally going to get to watch this. By the way, if you just want to see some mesmerizing GIFs, go look at algorithms on Wikipedia. There's so many GIFs of them just like executing, and it's fun. All right, so let's actually call this function. All right, let's see if we did it right. Does not appear that we did it right.
Does not appear, no.
Okay, so one thing is we're not going to do this turning bit until we've finished. So let's go ahead and put this down here at the bottom, because I think that might be messing us up a little bit.
Yeah.
Okay, still not perfect. So let's see.
I think it's got to be in the, because it starts the breadth first search function.
Let me just, oh, that's it. That's a quarter.
Is it?
On darn it. All right. Look at it go.
Nice. See, the search space is considering walls. Oh, it's probably just marking them even though it's killing them off.
Yeah, it's marking them even though it's they're like not like valid. I mean, why is this taking so long?
I think it's backtracking into places it's already visited.
Or
it's wait, I think it's probably considering things again. So at the beginning of the loop, are we checking? Are we throwing away if it's already there? If it's already colored? Yeah, we are.
Yeah, so what we do is we do this get value at 0. We mark it as visited. We check to see if this is if we're on a wall or not. And if we are, then we check to see in all of the 4 directions if they've already been visited. Oh! We did this backwards. We should be checking game field image here.
Yes. Yeah.
Yeah, and we should be checking the breadth first search visited on the outside. I was like, it doesn't matter. It does matter. And then
the outside is, have we already considered this? And the inside ones are, is this valid for anybody listening?
We need to mark it at the end instead of at the beginning. All right, let's go.
Nice.
All right, that's going faster. Yeah, that looks about right. So if we take out our pause, this is actually going to run much faster than it is right now. In fact,
right now,
I don't know. Let's see what happens if we take out our pause. Or
what if we put the pause at the end of the so just one pause per BFS?
Oh, yeah, we can do that. Let's do that.
So right now, for anybody listening, it's going to be about 30 milliseconds per pause because we can't actually pause less than that with our game loop.
Look at that. Look how much faster that is.
It's a little bit fast.
Yeah, I would say that's not bad at all.
Yeah, maybe hard. Maybe we can try it on our little guys later.
Yeah, maybe we should. And also, maybe we can just do this every frame. Maybe we don't need to just do it when we turn. I don't know.
We shouldn't go crazy here.
Yeah, let's not go crazy. Okay. So the other thing we need to do real quick is let's see, actually start doing checking the best direction. So what we're going to do is we're going to go into our breadth first search. We need to return the farthest depth that we reach. So what we're going to do is we're going to make a variable. It's going to be furthest depth. And with this furthest depth, we're just going to be using this math max function. And we're going to max our furthest depth and the depth of our current node. So if you remember, our current node is just the x, y, and then the depth. So we want to get the third thing, which is index 2. And we need to set our furthest depth to be 0 up here to start. And once we get our furthest depth, we can go ahead and return it. What's up?
This is a dumb point. I guess we probably don't even need the max here, right? We can just always set it to furthest depth, but that's just being cute.
You're
it doesn't
correct.
Make a difference.
Yes, you are absolutely correct. You know what? Let's just do that. Why not? Yes. So as Joey is mentioning, because we're doing BFS, we're always getting the furthest depth last. So whatever is the last in the queue will actually have the furthest depth. So we just need to keep track of whatever the most recent one was. Okay, now down here at the bottom, we're just going to go ahead and do a return, and we're going to return our furthest depth. All right. And so what we're going to do now is, so we're calling these two BF. Oh man, I should have done this differently, huh? So we're going to do an if right here. We're going to do a comparison. We're going to call our BFS the other way. We'll go ahead and put the left -1 and then just the top. And then we're going to do the left +1.
Oh boy.
The top. And then what we're going to do is we're going to do our 2 turns. So if this happens, then what we want to do is we want to change. Oh, what did I just do? Oh, nothing. Okay, we're good. Then we just want to change our direction to be either left or right, depending on this. So let's go ahead and get the variable. Let's get a set block. It's right here. And now we're going to have to think. Okay. So let's see. We're changing it so that we are now going in the left -1 direction, which is left, which is. Sorry.
Wait a second.
So this is less. Yeah, if this is less, then we're now doing it in the left +1 direction, and that is right, and right is 1.
Okay.
And that makes this one 3.
Yeah.
Yeah. So go ahead, get rid of that. And we can go to our down and just copy this because it's going to be exactly the same. And now let's do it for the left and right. So we're going to go ahead and do this right here. I could have done an or, but whatever. Yeah, over there. Make this left. Go ahead and do the top -1. And then the top +1. And And now we're going to say, okay, so if we're doing the top +1, that is down, so that is 2. And then the other one is 0. Because we did it 0, 1, I'm pointing in the direction that works for me, but 0 is up, 1 is right, 2 is down, 3 is left. That's the way I always do it. Okay, so we can just duplicate this, put it down here, and get rid of this.
See, the reason we can duplicate it is, we're just like, in one case it's turning right versus left, and the other case is turning left versus right first.
Yeah. Okay.
I think we can't see anything after the first one because the sprite is on top. Can we turn the sprite visible when we start the BFS and turn it invisible after we're done or something?
I don't think it. I think it's freezing. Let me go ahead and put this over here.
Oh, it is freezing. Okay.
All right. Why is it freezing? Oh, I forgot to set to block to false. That'll do it, folks. All right. Let me see if I can play against this now.
Nice.
Right. Froze again, but at a different point. See, this time it made the correct choice, right? So this is the correct choice in this situation because you have more if you go this way and around than you do the other way. But what's happened here is because we were at the 1, the very end, we are now searching infinitely into the void because it decided to check to the left to -1. That's no good. So there's a correct way to fix this, and there's an easy way to fix this.
For now, let's go with the easy way.
Yeah, let's go with the easy way. Okay, so where do I?
It probably fits a little bit better with the borders anyway.
Yeah.
Reset probably. Is that true?
Yep.
For reference, the easy way to fix this is just adding 1 extra pixel to the border so that there's always an extra pixel in the border.
Yep. There we go. And now, okay. Cool. So it definitely hangs for a second when it's doing the entire BFS, right?
I mean, it at least has a yield, right? Because it has the pause.
It's not hanging. It's just like it's
missing a frame. Yeah.
Yeah. Oh boy. Okay, so there's a problem. You see what happens?
No.
All right, so let's watch. I'll force this to happen. Okay. So we're just gonna let it go for a bit. Watch the red one. I'm just gonna try and stay alive and not kill myself. It's making all the decisions right now. All right, and it's about to box itself in. There we go.
Yeah. Okay. Yeah. We always have to actively cheat.
Yeah. So the issue here is we are getting into a situation where here I can draw this in the sprite editor. That might be the easiest way to do this. Let me go ahead and do a set background image. And we're going to draw out this scenario as it's happening. So we have our walls like this. Okay. We player 1 is making a wall that goes like this. All right. And then player 2 is coming up in this direction. It's going to hit the wall here and be like, okay, well, I should turn left here, right? Because I can turn left and then I have all of this space. But that's actually not the best way to do it, because what's going to happen is they're going to turn left. They're not going to check again until they hit here, and they're going to box themselves in, right? Because the correct thing to do here would be to turn here and here to go and loop back down. So Joey mentioned this before, that we have to kind of run the BFS on every frame. And so we do need to do that. And it's too slow to do that, but let's just do that for now, and we'll see how slow it is.
If we remove the pause, it'll probably be noticeably. It'll like cut the time in half. I think.
You're right. It probably will. Let's try that.
But let me think. We can't even just do a depth. This scenario wouldn't have been saved if we like cut it off with like a depth 40 max, because it's still 150 deep before it notices that it's wrong. Does that make sense? It has to go all the way across the top of the screen, so we need at least 160 depth before it would be able to know I'm wrong.
You're correct. Yeah.
So it does have to do the full one.
Yeah. Or just have a really high depth. Okay.
5,000.
So we're gonna do the full one, and we're gonna make this AI really tough to beat. Okay. So right now we're doing this check where we have 3 things. That's not going to work anymore, because, I mean, where we have 2 things. We're going to move to a check where we have 3 things, which are turn left, turn right, don't turn. So we need to put these 3 options in an array, basically, okay? And then based off the max in that array, so that we don't have to recalculate them 3 times, we will say, like, okay, that means that we want to do this. So let's see, we've got 12 minutes left. We're gonna be able to finish this. We wrote BFS in blocks today. That's pretty cool.
I think this is the second or third time we've done it.
Is it really?
I did it with Vivian once. I don't remember another time for sure.
I don't think I was here with that.
I think it was just Vivian and I don't remember what it was for.
Yeah. Okay. All right. So what we're going to do is we're going to, inside of here, we're going to do our breadth first search, and then we want to do another breadth first search. And the way this is going to work is we're going to make this first one is always going to be go forward. These other 2 are going to be our turn directions. So for go forward, when we're going up, we want to do top -1. So that, well, don't get rid of that. Hey, block 1. Chill out. There you go. Okay. And then we've already got our other 2. So that is +1. This one should be -1. And now we are going to compare our 3 things. So this will be fun. Luckily, we're only going to have to write this dumb chaining of if statements once. So we want 2 less thans and an and.
So separately do we not need to base off the facing to start?
We do.
Okay. Oh geez, wait. Could we just have an array of 4 things and have the one that is turned back will always be trivially bad? It'll always be trivially the worst because it'll die immediately.
Yeah, we can do that actually. Actually, yeah, that'll make this a lot easier. Okay, so what we're going to do is we're going to basically make this an array of 4 items. We're going to do this in, let's see. So we want to start with up because that's 0. So we want to start with our top -1. So that's this one right here. Then we want to do right. So because that's 1, that is the left +1. So this one right here. Then we want to do down. So that's going to be top +1. So we'll just go ahead and put that one there. And then we want to do the left, which is going to be left -1. And now what we're going to do is we're going to go away. We're going to, for each of these, just loop over and set our player 2 facing to be whatever the index is of the highest one. So we're going to make a variable which is going to be called best we're going to set best to be 0. We're going to do a four index loop from 0 to 3, because it's going to be 0, 1, 2, 3, 4. And we want to say if the array get value at 0 is greater than best, set best to get value at, this should be index. Set best to get value at index and set our player facing to be index.
Oh yeah, it's way easier.
Yeah, right. It's so much easier than what we were doing before.
Yeah, just in case we made a jump here that somebody doesn't understand, the reason we can do all four or should be able to do all four is because we'll be going backwards on itself, so it'll immediately lose and back out. It looks like that might not be the case here. Looks like
yeah, it seems like we did something wrong because we're just infinitely hanging.
Not ideal.
Did I just get rid of that move lock thing again? Bet you I did. Yep.
Well, we can just get rid of. I guess we want to visualize it for a moment.
We'll just have it run one more time like this. And okay, so yeah, it pauses for a bit. It's not actually that long.
Wait, it shouldn't. It should pause every. Oh, we didn't remove the outer if yet. Okay.
Okay, it's not. Yeah, what is it? Oh, we didn't remove the outer if. You're right. Gold star for Joey.
Ooh, gold star.
Yep.
Nice,
okay.
nice.
It is just. It's just committing. It's just immediately destroying itself each time. Look at our score. We've never done this well. So we went from trying to make the best AI to making literally the worst AI. Where you have to try pretty hard to lose against it. Let's see if I can. Yeah, okay. If I immediately hammer on the left, then I'll lose.
Okay.
All right. So let's see if we can figure out what's going on here.
Do we somehow get the search backwards? So left goes to top. Top is 0, top -1. That looks good. Top, right, bottom. That looks right.
So this should always favor going left.
This should always favor going left because left is given 2 equal choices. It will always favor going left. Yeah, but it's immediately turning right twice.
It's immediately turning right.
So let's see, list matches, index matches, best matches. Oh, no, it favors right. It favors right over left because it's greater than, not greater than equal. So first one wins.
Oh, you're right. You're right. Yeah, so it's just always turning right. Oh, okay. So then what's happening is our issue is if we go over to the breadth first search, we need to make our trivial one actually work correctly. So we need to duplicate this and we need to change this to be
okay.
The game field image, and we need to put this inside of an and. Because what's happening right now is that if it's only 1 pixel, it's going to get out of there, I think. So let's go ahead and put that.
I guess we don't need the border anymore then. This is just the correct fix.
All right, there we go. Okay. our game is slow as heck, but it now seems to let's just see it turn to the left. This is a Tron game I could actually win.
Mm-hmm.
Okay, cool. Yeah, so that looks about right.
Yeah. So it'll prioritize up first, right next, bottom, like the directions in order. That makes sense. Can we try just removing the?
Oh yeah, we'll remove the pause now. So like Joey was saying, pause actually, even though it says only pause for 1 millisecond, it's going to slow it down for more than 1 millisecond. There's a minimum amount of time that a pause runs for, and not just that. There's a chance that it will go even longer than that, because we don't guarantee that a pause will last for as long as you say it should. So that's just the thing. It doesn't usually matter in games because it works good enough, you know, not working on two things that are too timing critical. But let's go ahead now and take this out.
The fiber's probably killing it too, so we might just need to remove the parallel. For spinning up a new one, I guess it's just once per frame. That's not going to be enough. Never mind. It's probably fine.
Yeah, that's probably fine, but let's try it.
This is fine.
Well, it's definitely slower than it was before. Let's see what our FPS is.
We're probably going to get a pretty decent. No, okay. It does count it properly. That's good. Because it doesn't yield. Can we add an initial max depth of 2000?
There you go. See, I just made it way faster by blocking off a large portion of its search area. There we go. I made it faster again.
Nice, yeah.
Yeah, okay. So this AI is super impossible to beat because it's just gonna fill in the screen as perfectly as it can.
Yeah, you have to make at least one perfect turn on an edge.
Yes, right in front of it, I think, is how I would do it. Like that.
You have to go all the way to the right corner, like 2 or 3 pixels away from it, and then straight down. Then make the perfect left.
Okay, wait, I can do this. Let's do it. It's going so slow that I think I can make this happen.
It'll probably beat you if you make the perfect turn right now.
Oh shoot. Okay, so what I want to do is when it's going up, I want to go parallel to it, but be a few pixels ahead. Have to defeat this AI we've created.
It's a monster.
Yeah. It's gonna turn around now. Dude, but you saw that's how I could have done it, right? It was just because the game sped up that I was unable to make the perfect turns anymore. But then I could have blocked it off right there and would have trapped it. Because it's not doing anything based on what I'm doing. It's only doing things based off whatever the best decision is with just the game.
Yeah, in a vacuum.
Right. Okay, so what are ways we could speed this up? Can we
try just the max depth 4000 and see if it bailing out there helps?
Yeah, what is the max depth right now?
160 times 120.
No, it's not.
At the start it is. Almost.
No, it's not, because it's BFS.
But it only adds out on the ring. Oh, I see. Yeah. You're right.
I think the max is the diagonal.
Yes. But then then it does fail again in the left case, even if we just do the diagonal, right? Like,
yeah. My suggestion was going to be, well, this isn't a very good suggestion. Never mind. All right, well, we've got a meeting to go to, so we'll have to leave this for Antron part 3, maybe. In the meantime, I'm Richard, at Richard on the MakeCode forum.
I'm Joey at JWonderl on the MakeCode forum.
And we'll see you guys next time.
Bye.